Hello everyone. In this video series we are going to look at the mindset required for IIT Mathematics. We start with geometry and with some basic tools. Geometry starts with the triangle. It is the first closed figure. And in the triangle, right angle triangle is the most basic, and it is a very friendly triangle, if I may say so. If I have the hypotenuse and one angle, I can immediately get the other two sides. This is a very useful tool and you will be using it all the time. I insist that you learn this and learn to use this all the time. If you know hypotenuse, you can find the other two sides. If you know one angle, and the other angle of course is pi by 2 minus theta, that is known. Now how do I know which one is cos and which one is sine? So for that I'll take one more triangle and show you. And let this angle be alpha now, and this side be A again. The side opposite to this angle would be sine. So A sine alpha. And the side which is touching the angle will be cos. That's fine. Let's turn the triangle and see how we can do this easily. So for this we'll take a semicircle, and we know that inside the semicircle all the triangles are right angled. This is a right angle triangle, and the hypotenuse is 2r. If we have one angle, so one angle is important, without that we can't do it. If we know one angle, the side touching the angle will be 2r cos alpha, here it is theta, cos theta, and the side opposite to the angle will be 2r sine theta. So that does it. There is another very useful application of this tool. Let's look at that in the coordinate axis. In the x and y coordinate, if I have any point and I know the length from the origin, let's say that is B, and if I know this angle and I simply drop a perpendicular here, and we get B cos theta and B sin theta. And that becomes the coordinate of this point, right? So finding a coordinate of a point, if the distance from origin and the angle is given, we can immediately find the coordinates of that point. So this is also given this another notation called r theta, which is not exactly the coordinate but the two parameters given to you through which you can find the actual coordinates. Coordinates means this x distance and the y distance to the point. These are called polar coordinates, as is known to you, I suppose. Now we'll see another interesting application of this tool that we have learned today, the simple tool of r cos theta and r sin theta. Look at this circle, center, radius is r always. Suppose this is theta, this is alpha. You can immediately tell the coordinate of this point as r cos theta, comma r cos r sin theta. Similarly, this one is making an angle of alpha, so if I drop a perpendicular, this will be r cos alpha, r sin alpha, so this coordinate becomes r cos alpha, r sin alpha. As simple as that. we'll look at it a little more. If this coordinate you have to find, let's say this is our R, and this angle is theta. So again we get in this triangle R cos theta and R sin theta, but here the theta is in the negative side. So we get minus R cos theta, comma R sin theta, because sin theta is in the positive direction. Similarly, let's take one more, and we have to find the coordinate of this point. Let's say this angle is alpha. So if I drop a perpendicular here, we get R cos alpha and R sin alpha, but both are in the negative, so this will be minus R cos alpha minus R sin alpha. Always remember, cos comes first, sin comes second, because in the x and y coordinate, if you look at the triangle once again, the cos is in the x direction and sin is in the y direction. Okay, so we'll see more interesting application of this in the next video. So this coordinate will be 30 degree, so cos 30 sin 30. This will be 60 degree, so cos 60 sin 60. What about this one? It is opposite to that. So if I drop a perpendicular here, we'll take this angle, we'll find a right angle triangle. We'll always look for a right angle triangle. So this is 60, this is 30, this is 30, so this is 60. Opposite side, so this is 30, so this is 60. So we have one cos 60 adjacent to the side angle, and opposite to the angle is sin 60, but this is in the negative, this is the negative, so minus cos 60 minus sin 60. Notice how the opposite ends of a diameter have simply the negative numbers. Similarly, I request you to find the coordinates of all the other points on the clock. Let's extend this a little bit more. We have a circle, and let's try and draw a hexagon. And 6. We know from our theory that these angles are 60. So we have so many equilateral triangles here. 1, 2, 3, 4, 5, 6 equilateral triangles. Now this again, this is R and this is 30. So this coordinate becomes R cos 30, R sin 30. Similarly, this is already known, 0, 1. This, you can look at this is also 30, so R cos 30, R sin 30, but cos is in the negative side, this being the origin, so minus R cos 30, R sin 30. Similarly this. Please solve this by yourself. Let's look at a higher order problem. Imagine there is a circle and there are n-sided polygon inside it. Can we attempt